third kind of chi-square test that we can do is called a homogeneity test. And what we're looking at here is the distribution in a group and seeing if there's a difference between them. So in this example, we have male and female, and then we have living situation. So we have two categorical variables. Essentially, what we're doing is the same thing as the test of independence. But here it's called a homogeneity test. The analysis is very, very similar, so you can think about it in the same sort of way. Two categorical variables, and so we have some observed data of the number of males or females in each living situation. So dorm, apartment, with parents, other. And so these totals are our observed data. We have 250 total male students, 300 total female students in the sample. And so they each have their own population, and we want to see if the population is homogeneous. So is the male population the same as the female population with respect to this living situation variable? Okay, but the structure is exactly the same as the independence test, and so the analysis is exactly the same as the independence test. We need to figure out what those expected values should be if the population is homogeneous. In other words, if there's no difference between males and females when it comes to what type of living situation they have. So let's start by finding the observed proportions so we can look at that, and we will use this information to get us to the expected, or lead us into the expected. So what are the observed proportions? So for males, we have 72 out of 250 in dorms, so that's 0.288 or 28.8%. And so each of the values here is the proportion of this gender in this category of living situation. Okay. Now, if the population was homogeneous, then what we would expect is that the same proportion of men in dorms would be the same proportion as the number of females in dorms. So 0.288, 0.303. We see differences along the line here. So they're not exactly the same, but are they different enough to say that the population is inhomogeneous with respect to this living situation variable? All right, so we'll do a similar thing to the independence analysis and find the pooled proportion. And so find the total number of males and females together in dorms. So 72 plus 91 gives us 163 students in dorms out of 250 plus 300, so out of 550 total students. So the pooled proportion is 0.296. So if the populations were homogeneous, what we'd expect is the dorm values should be 0.296. And we can do that in each of these categories, and so we have pooled proportions in each. All right. From those pooled proportions, we can calculate the expected number in each dorm situation. So in the same way we did for the independence example. So we take the 0.296 in this case, multiply it by 250 to get the number of males, and multiply it by 300 to get the number of females. So that's where these numbers come from. So 0.296 times 300 gives you 88.8. So we expect 88.8 females. Obviously can't have 0.8, but the numbers don't know that they need to be whole numbers of people. And so that's our expected value that we compare to. And do the same thing in each category to get all these other expected values that we can then compare with the observed. Once you have the observed and expected, the analysis is the same as before. Okay, so again, I'll delete the answer and then we'll calculate it again. we're running a chi-square test. And I've organized the data, so here we have all the observed and here are the expected. If you're doing this in Excel, you really want to have your data organized this way as opposed to how it is on the PowerPoint. And that's because when you get to this stage here, if you have all of the observed data together, you can just highlight it. And then you can highlight the expected data the same way. The other thing I should mention here is that you can do this as long as these categories are in the same order. So if dorm is the first column over here, dorm has to be the first column over here. If you mixed up these columns, Excel would get confused, and it would always assume that you're comparing these values to these values. So if this set was the apartment data, then it would give you the wrong answer. So you want to organize it so the observed data is all together, the expected data is all together, and they're in the same order. So dorm apartment with parents other, dorm apartment with parents other. And now when we hit enter, the chi-square test gives us the p-value of 0.017. Okay. If you want to go through it the longer way here to see that you get to the same answer, we calculate the observed minus expected values, square it, divide by expected, same as before. It gives you all of these different entries. You add these all up, and that will give you a chi-square of 10. And then you can use the chi-square distribution function. M5, that's the chi-square value. 3 is the degrees of freedom. So why is it 3 degrees of freedom? We have two categorical variables. This one has 4, so 4 minus 1. And this one has 2, so 2 minus 1. So 4 minus 1 times 2 minus 1 gives me 3. And then the chi-square distribution is the left tail probability. Subtract it from 1 to get the right tail probability. That's our p-value. And so those numbers match. It's a p-value of 0.017. Which is less than 0.05, so again, we reject the null hypothesis. So it appears that these two populations are not homogeneous, right? They're not the same distribution with respect to this variable. There's a difference between living situations of males and females that we have sort of uncovered with this analysis.